Here is a challenging fraction problem. So go ahead, read the question and see if you can solve the problem on your own. If for some reason you cannot solve the problem, feel free to watch the video. Let's go ahead and read the question. A parking lot had American-made and Japanese-made cars only. One-fourth of the cars in the lot were Japanese-made and the rest were American-made. One-fourth of the blue cars in the lot were Japanese-made. One-third of the red cars in the lot were American-made. There were one-third as many blue Japanese-made cars as red American-made cars. If one-third of the Japanese cars were neither blue nor red, what part of the American cars were neither blue nor red in that parking lot? I will solve this problem algebraically. So if you can solve it in a different way, that's great. If you can't, feel free to watch the rest of the video. So here is my solution. What I have here is a table. B stands for blue cars, R stands for red cars, B, this symbol here, it reads neither blue nor red, and this is the total. I did start with the assumption that the total number of red American cars is X. Why did I do that? Because if you read the question carefully, you can conclude that this is where the whole thing hinges upon red American cars. So I'm going to start with that assumption that there are X red American cars. So I'm going to go back and forth and see what I can glean from the question. From this, where can I go next? So let's read the question. Okay, what I have here is, let's read this line. This line that starts right here. There were one-third as many blue Japanese-made cars as red American-made cars. What is that supposed to mean? Let's go back to our solution table. So this has to be one-third of this. That simply means this has to be x over 3. Okay? Make this eraser a little bit bigger and scratch my solution. So I have one more thing for my table. Okay, then let's see where we can go next. All right, one-fourth of the cars in the lot were Japanese made and the rest were American made. Well, I'm going to come back to it. One-fourth of the blue cars in the lot were Japanese made. So let's see what I can use, how I can use that statement. One-fourth of the blue cars were Japanese made. What is that supposed to mean? If these are blue cars in the parking lot, this is one-fourth. So this has to be 3/4. So if this is 1/4, this has to be 3 times x over 3. And 3 times x over 3 is x. Excuse me, is x. So I have one more expression on my table. I need to fill out the whole table. Okay, let's go back and read the question once again. Okay, this line right here. One-third of the red cars in the lot were American made. So let's use this one now. One-third of the red cars in the lot were American made. Okay. Okay. One-third of the red cars were American made. That tells me this is one-third of all the red cars. Okay. What is that supposed to mean? If this is one-third, this has to be 2/3. If one-third of the cars, red cars, are American made, 2/3 of the red cars must be Japanese made. If this is one-third, 2/3 has to be twice that, and that's what I have here, 2x. Okay, so I'm going to go back and read the question once again. One-third of the let's read this line now. Let's take advantage of this line. One-third of the Japanese cars were neither blue nor red. Once again, one-third of the Japanese cars were neither blue nor red. Okay, so this is, sorry, one-third of the cars were neither blue nor red. So this has to be one-third of all the Japanese cars. and that tells me these two together has to be 2/3. Okay, this has to be 2/3, and if you add 2x to x over 3, you're going to get, let me see what you're going to get. You're going to get 7x over 3. So this has to be 7x over 3. Let's write it down right here. When you add them, it's going to be 7x over 3, and you know how to do it. Okay, if this is 2/3, 1/3 would be what? If this is 2/3, 1/3 would be half of that. So half of this number is going to be 7x over 6. Over 6. That's what goes here. Once again, go back and read the question and make sure you get this step. So I'm going to erase all that and see if I can scratch my table. 7x over 6 as promised. Okay, now I have all these numbers. If I add x plus 3 to 2x to 7x over 6, I will get 21x over 6. Okay, I have two more numbers to find, just two. Numbers or expressions. All right, I'm going to go read the question once again. Okay, the question says 1/4 of the cars in the lot were Japanese made, the rest were American made. Let's take advantage of that statement. 1/4 of the cars in the lot were Japanese made. So this is 1/4 of the cars. So this has to be 3/4. If this is 1/4, if 1/4 of the cars in the lot were Japanese made, automatically I can assume or conclude that 3/4 of the cars in the lot were American made. If this is 1/4, 3/4 would simply be 3 times that. So what goes here is simply 3 times 21x over 6, and you can cancel. So basically 21x over 2 is what goes here. Again, a crucial step. You want to go ahead and read the question, make sure you get it, and then you want to make sure you follow this step because it's an important step. So let's go ahead and see what I have here. I have 21x over 2. Now to find this expression for this spot, all I need to do is from 21x over 2, I have to subtract x twice, or from 21x over 2, I have to subtract 2x. So to find this expression or number, I need to do this. And we're going to scratch our solution and see what we have here. We have 17x over 2. So we have our complete table, and let's go back and see what the question is asking us to do. The question wants us to find what part of the American cars were neither blue nor red. Okay, we can do that. Okay, these cars were neither blue nor red, and this is the total number of American cars. This is the total number of cars that are neither blue nor red. So my answer should be 17x over 2 divided by 21x over 2. 17x over 2 divided by 21x over 2, and you can cancel x over 2, and you're left with 17 over 21. That's your final answer, 17 over 21.